0 to L. Please find out that. So here mm cancel. So like 1 by L into x into dx, like x square by 2. What are the limits? 0 to L. Because of mm get cancelled. Right? Now here 1 by L, apply the limits. Upper limit minus lower limit according to just limitation methods. Okay. Now here L square by 2. So LL get cancelled. Finally, what you will get? L by 2. That is the XCM value. XCM. So what we notice from this point? What we notice from this point? Where is the center of mass for given body? Exactly located at the center of the rod. Simply that is the point. Right? You got it?
Sir, one say how it got x square.
This one, x square by 2.
Yes, sir.
Yeah, okay. In the previous class, I just give an instruction to you. Learn just integration. I will give just general form of integration. Okay. First, make a note down, please. Can I write the formula?
Yes, sir. Explain again.
Can I explain once again?
Yes, sir.
Okay.
Yes, sir.
I'm using just a general formula here. Integration of x power n dx. This is the formula. X power n dx. What is the formula? X power
1 by
1 by n plus 1. This is the formula.
sir.
Yes.
Then why it became L square by 2?
Substitute just limits. Instead of x, what you have to write?
Okay, sir.
Upper limit. What is the upper limit? L. Directly substituted in the x value. So instead of x, we can substitute L. L square by 2 minus lower limit. Instead of x, we can substitute 0. 0 by 2. 0. Can I write? So minus 0. So finally, L square L cancel. Finally, L by 2.
Sir, by denominator m will come.
Total mass. I said already. What is the integration of dm? If you are going to just add all these points, if you are cutting to so many parts actually, if you are adding all these points, what will you get finally? Total mass of the rod, that is m. Right?
Yes.
Actually, I consider only small portion of the given rod. That is gm. If you are divided into just a uniform rod, so many parts actually. If you are just going to adding all these massive particles, what will you get finally? The total mass of the rod. What is the total mass of the rod? I said already. Yeah? I just simply written that part. Okay? In formula also just mention that point. Okay?
Sir, the upper limit Ly came, sir.
Upper limit Ly came. Just I will give the just one clarity here.
Sir, can you explain again?
Okay, I will explain. Okay. Okay. Try to understand. Once again, I will say. Before just I want to explain. Try to understand this formula. Integration of x power n dx. What is the formula?
X power n plus 1 by
n plus 1. For example, for better understanding, just I want to give one example. Integration of like x power 9 into dx. What is the answer?
X power 10 by 10.
X power 10 by 10. Right? Very good. If you substitute just the limits from 1 to 2. From 1 to 2. Okay? Can I substitute directly? 1 to 2. Now what happens? Instead of x, what you have to write? 2 power 10
2 power 10 by 10 minus 1 power 10 by 10.
minus
1
1
power 10 by 10.
by 10. Is it okay? This is the substitution. Okay now. This is the approach to substitution. Okay now. How to just substitute the limits.
1 and 2.
Yeah.
Why you took 1 and 2?
Just example for better understanding. Okay. Otherwise, just to take 0 to 2, no problem. Okay na. So what happened? So 0 power something, you'll get the 0 value. Finally, 2 power 10 by 10. So here 0 and 2. 0 is a lower limit. 2 is a upper limit. Okay. So here 0 is nothing but just I consider only 0 to 2. Don't bother about just limits. Okay now. As you wish, no problem. How to substitute the just limits? That is very important.
Okay, sir. Okay,
Are you
sir.
getting my point?
Yes, sir.
Yeah, exactly. Please. Now, if you understand this information, we can understand our just derivation also. I want to explain once again. Please try to understand this one. This is very, very important. If you understand one derivation, we can understand remaining also very easily. Now, try to understand. Now, here, this is a uniform rod. Once again, try to understand. So, please pay the attention here clearly. Now, this is a uniform rod of length. How much it is? Just response immediately, please.
L.
Yes, exactly. This is the length of the uniform rod equal to capital L. What about this one?
DM.
This one. This is called elemental mass of uniform
Mass.
rod length. How much it is? L. Very
L.
good. The distance of this elemental mass dx.
D.
Yeah, okay. So this is the best example of 1D because of this is x-axis. Okay. So simply we can write xcm. xcm equal to, so what is the formula? Integration of, tell me now. X into,
DM by
yeah, very good. By integration of,
DM.
very good.
DM.
Immediately, just after just formula, immediately how to find out the DM value. How to find out the DM value. Right? Now here, this is a, for L length, what is the mass?
Total mass.
Total mass, I said already. Total mass equal to capital M.
Yes.
For L length, what is the mass? Capital M. For unit length, what is the mass?
M by L.
Exactly. For unit means 1 by 1 M by L. I need for DM value, how much the mass? M by L into what the distance?
DM.
Yes. To understand this point, we can understand this type of just derivations also.
Yes, sir.
Right? Now just substitute this value. Now here integration of what are the limits here? 0 to L. Lower limit equal to 0. Upper limit equal to how much it is?
L.
Capital L. Okay. Don't confuse, please. Now here I'm substituting the values. 0 to L. X into whatever DM value. Capital M by capital L into X whole divided by integration of DM. I said already, what is the value? Capital M. Can I write correctly? Yeah, okay, capital M. Now, just apply the integration of this function. What is the constant values here? Length is constant, M also constant. What are the variables here? This is a variable function. What is the variable function here? M by L, just take out outside by M. What are the remaining terms?
X
0
dx.
to X into dx. Is it variable function or is it variable function or constant function? Variable function. Variable function in x. Am I right?
Yes, sir. Yes,
Here
sir.
is just variable with respect to dx. Now directly I am writing just mm just cancel. M by lm. Mm cancel. What is the final? 1 by L into what about this value? X square by, I said already that formula. Square by 2. What are the limits? From 0 to L.
L.
Is it okay? Now simply we can write 1 by L into upper limit is L square by 2
minus 0.
0 by 2 automatically 0. So now what is the answer? L square by 2L.
L.
L answer L by
2.
So what is the meaning of L by 2? Where is the center of mass is located?
At the midpoint.
Exactly. The midpoint of the just given rod like this. So this is the center of mass of the given rod. Because this is a uniform rod. That's why where is the center of mass is located? Exactly the geometry center of the given body. I said all at that point previously.
Yes, sir.
Should be clear. Can we try just one more example?
Yes, sir.
Yeah, once please check it. I'll just give you one more example. This is very, very important.
Sir, not visible last.
Okay. Once please write down. Just simplification, that is nothing. Okay? Is it okay?
Yes, sir.
Yes,
Yes,
sir.
finally, what is the answer? L by?
2.
Yeah, okay, very good. I will give you just one more example. Based on the uniform rod. Again, I want to give the same notation. Rod of a linear density, very important. This is also linear density. Linear density. Basically, linear density symbolic representation is lambda. Lambda, okay? So lambda equals to, I want to give the value for this for lambda. Kx square by some constant kx square by capital L. Where L is the linear length of the rod. Where L is the, I'm writing here, where L is the
Linear length.
length of the rod, not linear. Length of the rod. Length of the rod. Okay, right? Length of the rod. Should be clear? Now this is the problem. Now this is a rod. So this is a fixed. This is like fixed point. So like this is the origin. Again consider the, what is the first step? Consider elemental
Mass.
mass. Yes, point. So what is the elemental mass? This is a dm. I want to consider this is a dm. This is dm. So dm is, this is automatically dx. What is the length of the rod? Capital L. Capital L. What about this one? Like dx. Like x. Okay. Right. So how can you calculate the center of mass of this body? With some information actually. Some information. How can you calculate the center of mass of the given body? So what is the formula? What is the formula? XCM equal to
Integration of
dm by total mass capital M.
M.
But here don't take just a capital M because of just giving some value. Directly you can consider dm value. First, what you have to find out?
D value.
dm value. First, you should find out dm value. Right? The dm is equal to dm equal to, you can write linear density into some distance. dm equal to linear density into some distance like dx. How can you calculate the students? Hello?
Yes, sir.
Now dm equal to lambda into delta x. Lambda into delta x. This is the formula. So delta already given. kx square by L into dx. This is about dm value. First of all, you should find out the dm value. Now substitute this value in this expression. Now integration of x into what about dm value?
kx square by L.
L into dx. What are the limits? 0 to limits
L.
to
L.
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 0 to L. What about denominator value? Now tell me.
Kx square by L.
Very good. Integration of dm value. Again, have to write on this value. Kx square by
L.
into dx.
K by L is constant.
L. Please start with the problem.
K by L constant. Sir.
Yeah, please. Kx square by L or k by L. Kx square by L both cancel actually. What is the remaining term?
Integration of x to x.
Now here x into x square, x cube. K by L both cancel. Now what about remaining terms? Now x into x square, x cube. So x cube means integration of x cube. X power 4 by
4.
4. X power 4 by 4.
By
Limits from
0 to L. 0 to L.
by. So take separate KL value otherwise if you are confused.
K by
By
K by
K
L. L.
what
X
about
by 3.
x square? So x cube by 3, 0 to L. Simplify this value K by L get cancelled. What are the remaining terms? Like L power 4 by 4, right? By L cube by 3. I'm writing just over
3
the.
by 4.
Here, write please.
The integration of dm is capital M, sir.
Integration of m is?
dm is a capital M, sir.
Yes, exactly. dm equal capital.
So you can directly write capital M.
Integration of dm equal to m. Like integration of dx, how much it is? Integration of dx, x. Integration of dm, like m, not small, not capital M. Integration of dl, L. Integration of dt, how much it is?
T.
Exactly. So these all are variable functions, not constant functions, okay? If it is variable function, yes, we can apply the integration. So that's why in integration only we are using just limits. Okay?
Okay, sir.
That length variable from just 0 to L. What's the final answer here?
By
Tell me.
4. 3L by 4.
Yeah, very good. Okay. Can I have this one? Okay. Now what is the final answer? L power 4 by 4 whole divided by L power 3 by 3. Simply we can write L power 4 by 4 into 3 by L cube. So L cube cancels. Finally, what you will get? 3L by 4. What is the center of mass? Where is the center of mass located?
3L by 4.
So therefore, HCM equal how much it is? 3L by 4. So this is L actually. So here just existed center of mass. So this is the approach to develop the center of mass of the different bodies. So this is uniform bodies. If it is a non-uniform body, how can you find out the center of mass? That is very interesting topic. Right, please write down.
Down not visible, sir.
Okay. Down, huh? Okay, right. Okay, sir. Jayati sir, okay.
Sir, how much time it will take?
No
No problem.
Within
will
4
wait.
minutes, I want to finish, sir. No problem.
No problem. I will wait. No problem.
Okay, sir. Okay. Students completed?
Yes, sir.
Yeah, okay. Had any doubt in this?
No, sir.
Yeah. You got it? How to calculate center of mass of the uniform bodies?
Yes, sir.
Okay. So now try to understand. If it is uniform body, where is the center of mass located?
At the midpoint.
Exactly at geometric center of the given body. For example, can I rub this one? For example, if I consider just a ring, where is the center of mass?
At the
At
geometric
the
center.
center.
For example, just I want to consider one more example. Try to understand this one.
Jagdish Garu, please raise the hand, sir.
This is semicircular ring. This is a semicircular ring. Where is the center of mass? Now tell me.
At the boundary, sir.
That's the boundary. Along x-axis or y-axis? Now tell me. Along x-axis or y-axis? So here we cannot just find out the center of mass of the given body. Just we apply the both methods like symmetry as well as method of integration. We can use just those methods. We find out the just center of mass of the semi-circular ring or semi-circular disc, whatever it may be. Okay. So for this situation, just we are just utilize the method of integration is the ultimate method. Okay. So that's why I said that point previously. So where is the center of mass of the non-uniformly massive bodies? Now tell me. Just line the boundary of the given body. For example, if you assume just this body, this is a given body. So for example, if you assume that this is center actually, let it because this is a radius of the given ring. So first assume what is the symmetry of this body. This is the symmetry of the body. This is the symmetry of the body. So where is the symmetry of the body? Along the y-axis. Along the y-axis. So immediately go for the just x-axis, xcm. What is the xcm value? This is xcm actually. So what about xcm value here? What about xcm value? So immediately this should be equal to 0. This is the origin. This value acts as the origin automatically. We can just observe the center of mass lie on the given boundary of the given path. Am I right? So this is the approach to find out the center of mass of the semicircular ring. Now practice what I discussed, just linear bodies. Okay, tomorrow I will continue just about these bodies. Thank you. Thank you, children. Have any doubt?
No.
Okay. Okay. Thank you.
Thank you, Nagaraj. No, thank you, Nagaraj Garu.
Thank you, sir. Thank you very much. Okay.
Okay. If you have any doubts, please ask them. No doubts. Okay, thank you, sir. Thank you very much.
Thank you.
Jagdish Garu.
Sir, okay, I'm coming.
Okay, sir. Okay. Welcome, sir.
Okay, sir, I will start. No problem. Yeah, I think I'm audible to all.
Yes, sir. Yes, sir.
Yeah, okay. So the last class we discussed here degree of unsaturation, planar and non-planarity of the molecules. So now today we are going to discuss about the nomenclature of the organic compounds. So nomenclature of organic compounds. And first of all, here the term here, the nomenclature, it means the system of naming of organic compounds. It is a system of naming of organic compounds here. So generally, in the case of aliphatic compounds, already we discussed here before what is aliphatic, what are aromatic classification. Generally, majorly in the case of aliphatic compounds here, major two systems are there for nomenclature. We are used generally. And first one is a trivial system. Two systems are there. So trivial or common system. So trivial or common system. And second one here, IUPAC system. So here For naming of organic compounds here, for especially in the case of aliphatic compounds here, we are using two systems. One is trivial system and second one is here IUPAC system here. So first of all, let us see about trivial system. So first of all here, trivial system. So here trivial system means what? First of all, in the earlier stages, in the development of organic chemistry here, generally organic compounds were named after the source from where they are first isolated. Based on that, just they are giving the names. But where actual IUPAC system is most important in this chapter. But before going to IUPAC system, first of all, we are going to discuss here now common system. Commonly, we are calling few names based on their source, where they are isolated, how they are prepared. Based on their source here, generally we are getting few. We are giving few names. Those names are here. Generally, we are calling trivial system or common system. For example, we know already urea. Urea generally, how this name is coming? Urea, its name since the compound was first obtained from the urine of the mammals. Okay, urine of the mammals like that. That's why the name is urea. We are calling generally. So like that, few names based on the source we are giving. For example, methyl alcohol. Methyl alcohol, that actually called wood spirit also, because from the destructive distillation process of wood we are getting that methyl alcohol. So methyl alcohol generally we are calling wood spirit here. So why wood spirit we are calling methyl alcohol? Yeah, it is obtained by the destructive distillation of wood. So based on the how they are preparing, based on the process of preparing our source, we are giving few these names here. For example, we know already acetic acid, all of you. Acetic acid, we know that name. So acetic acid actually, its name is coming from the Latin name acetum, from the Latin name. Acetum means what here in the Latin name here? Acetum means here nothing but vinegar. Acetum means here vinegar. So then it is present in the vinegar. So like that here. And also formic acid. Formic acid is another example of organic compound. It is derived from here formicus, which is a Latin name. Formicus means here red ants. Generally, red ants produce this acid here. So like that, based on their source, based on the process of preparation, we are giving names here. Those names are called here trivial names or common names. That system is called here trivial system. Okay, so like this, so many are there. Citric acid, for example, we know citric acid. It is coming from citrus fruits here. It is present in the citrus fruits. So it is called here citric acid. Like that. So these all names are called here trivial names or common names. So still few more examples I will give you for trivial names or common names. And I am taking example, formula I am taking. So generally it is called methane. We can call it as methane is a trivial name, or C2H2. We are calling this is called acetylene. Or already I told you CH3COOH. This is called here. Yes, acetic acid is the common name or trivial name only. So acetamide, CH3CONH2. So many names are there. Just I'm giving only few examples. Okay. And we know already C6H6, it is called here benzene, is the common name only. So like that here, we can say so many. Or if I'm taking CH3, this is called here acetone. We can write so many examples. So these are the just few examples of formula and the common names. So these are nothing but trivial names, or we can call common names. Common name just we have to remember. Sir?
Sir, can you go a little up, sir? I didn't write.
Yeah. Yeah, that one.
Thank you, sir.
Yeah. Citric acid, citrus fruits. And CH, for example, methane. C2H2, acetylene. CH3CO, acetic acid here. CH3CONH2, acetamide. C6H6, benzene. And already I told you before, NH2CO, NH2. This is called urea. This is the formula of urea. We can write so many examples here. So these are common names or trivial names. Now let us know about the IUPAC system. So that is the main important IUPAC system. And actually this is the unique property of catenation and isomerism, generally carbon forms large number of organic compounds. In the starting, we discussed here why carbon forms more number of compounds because of its unique property. What is that property? Means we discussed already. One of the reason is catenation, another reason is isomerism, multiple bonds, tetravalency, hybridization, everything we discussed here. So here for all compounds, how to name? Because common names we cannot say for all. So many compounds are there. So in the end of the 19th century, number of organic compounds known are very, very large number of compounds we are getting. And it is very difficult. It is very difficult to remember them by their common names or trivial names because we cannot remember easily their common names. So to systemize the nomenclature, so of all the nomenclature, just they introduced in that time here, few rules they developed here, few modifications they did. So time to time, and finally we are getting a few rules for nomenclature of the organic compounds, and later they updated again, and we have to discuss those rules and how to say the name of the organic compound. Any compound, based on the rules, we can give the name. So that naming of organic compounds is nothing but nomenclature. Okay, so first of all, before going to do the names for all the compounds here, first of all, we have to discuss the rules. Before going to rules here, general rules to discuss the nomenclature. So general rules for IUPAC nomenclature. General rules for IUPAC nomenclature. So in this, some terminology, some points we have to discuss in these rules. So here, this IUPAC system is the most widely used here, the system of nomenclature in the organic chemistry here. So most important feature of the system is that here, they are giving any molecular structure, every molecular structure having only one IUPAC name. We cannot write more than one IUPAC name, unique it is. Every molecule, every structure having only one type of name only is there. So that IUPAC means what here? IUPAC means International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. So this is like a board, like intermediate board, IUPAC board is there, and every changes in the chemistry actually they have to see and they have to check and they have to modify. So after that we can give the names here. The IUPAC name of any organic compound essentially majorly consists of three parts. For any organic compound, when you are giving the name, majorly it consists of three parts, three main parts. What are those here? First one is word root. First one is here word root. On some books they are giving root word. Both are correct only. Word root or root word. And second one, majorly three parts I told you, suffix. And third one, again here we can write here prefix. So these three are very important while you are writing the name of the any organic compound. So one is word root or root word, and second one is suffix, and third one is here prefix. And first one, let us discuss about root word or word root. So root word or word root. First of all, this is the basic unit of the name. This is the basic unit. First point here about root word, and it denotes the number of carbon atoms present in the parent chain. What is parent chain? We will discuss later. So present in the main chain, parent chain or main chain. So how many carbon atoms present in that parent chain? That represents the root word here. So parent chain means large. What we can call parent chain means. Parent chain means here largest possible chain of carbon atoms. So that chain is a continuous chain. Largest possible continuous chain of carbon atoms. Okay, but you have to include a functional group also. We discussed already, including functional group or a double bond or triple bond, multiple bonds also. We have to include them. So later again we will discuss that. And these chains from 1 to so largest possible continuous chain here of carbon atoms, including functional group. Let us take one example I am giving you later. And first of all, the chains from these chains here, we are giving a special root words. For each and every number of carbon atoms here, there is some Greek number roots we are giving here. First of all, based on the chain length. If the longest chain or largest possible chain, so chain length, it contains only one carbon atom in the chain. So then what we have to use the root word for that? If it contains one carbon atom, we have to use the root word eth. Okay, like it, we are going to give so many are there. So 2 carbons here, we have to give the root word eth. 3 carbons means we have to give the root word prop. Sometimes their continuation with the A letter also they are using based on the structure. Prop or proper. Okay, prop. Generally prop we are using mainly. And 4 carbons means here but or buta. Based on the structure, A also we have to add, but not for all. Generally but we have to use here. And C, 5 carbons means generally pent. Okay, and 6 carbons means we have to use here eggs. Okay, and 7 carbons we have to use here hept. Okay, hept. And this A letter only we have to use in few cases only. That's why I'm not writing exactly and on the side of the word here. And 8 carbons here we have to use oct. Yes, 9 carbons.
9.
Non. Okay, non. 10 carbons. Then we have to use here.
Delta.
Yeah. So these are for the first 10. Majorly, we are using these 10 root words only. We have to remember. Okay. So everyone should know the at least 10 carbon atoms root words. But actually, there are 100 root words are there. Okay, we can use 100 root words minimum. But most familiar root words, most number of times we are using 1 to 10 only. Majorly. Okay, and we have to know 11 also. Just I am giving a clue. 11 carbons means here what we can use undec. 12 carbons means here dodec. And 13 carbons, tridec. And 14 carbons, if the longest chain containing 14 carbons, tetradec. And 15 carbons here, yes, pentadec. And 16 carbons, we can use here hexadec. Yes, 17 carbons here, heptadec. Okay. And 18 carbons here, we can use octadec. Sorry. So, this one not there here. And 19 carbons here, nonadic. And 20 carbons, icos. Okay. So, these are for 20 carbon atoms I wrote. But if I'm asking for 21 carbons, then unicos. 22 carbons, doicos. Before already we used for 11, 12 like that only. If 23 carbons, triicos. Okay. And 24 carbons, tetraicos. Like this. Already here also same type of root words we use here. Tetradec, pentadec, hexadec, heptadec, like that here, anicos, doicos, triicos, tetraicos, pentaicos, like that here we are getting. And what about 30 carbons here? Tricant. So 25, 26. 25 means pentadec. 26 means hexadec. Sorry, here 24 means tetraicos. 25 means pentaicos. 26 means hexaicos. 27 means heptaicos, 28 means octaicos, 29 means nonaicos. Because we can say, because 11 to 20, if you know, we can say 21 to 30 also. But 30 is somewhat different. Tricant. 30 is tricant. But if you want to write for 31, again here, what we can use? Untricant. 32 means do tricant. Just we are changing. This this do, this tri, tetra, these are all common. But this part only different here. 33 means tricant. 34 means tetra. 34 means tetra, tricant. Here tricant is common. Okay. 31, 32, 33, 34. Again we are getting like this here. 35, pentatricant. 36, hexatricant. 37, heptatricant. 38, Octa tricant. 39. No, not tricant. And what about 40? Here tricant, here tetracant. Okay. Tricant after tetracant. So like 50 carbons, pentacant. Again between the 51 to 60 as usual again. And 60 carbons, hexacant. 70 carbons, heptacant. Again, here also similarly we are getting same words. And 80 carbon here, octacant. Okay. And 90, nonacant. What about 100? HECT, hect. Hect. I think you know hect, how you can remember. Yeah, I will give one shortcut for 100 carbons. We know already hectares. Hectare means 100 acres. Okay. Hectares means 100 acres. Like that here, hect means 100 carbons. In the longest continuous carbon chain, if it contains 100 carbons, we have to use the root word hect here. So I think you got clarity here, but no need to remember all of these. But easy also. Remembering is easy only. Once you see here, common points only here we are getting. Common words only. But 1 to 10, most important for exam point of view also. This 1 to 10 root words very, very important and very easy also we can remember. So here first of all root word means what here? Number of carbon atoms present in the longest continuous carbon chain. So here 1 carbon, meth, 2 carbon, eth. These are very important. 3 carbon, prop, 4 carbons, but, 5 carbons, pent, 6 carbons, hex, 7 carbons, hept, 8 carbons, oct, 9 carbons, non, 10 carbons, dec. So at least remember first 10. Later you can read remaining also. But the first 10 is very, very important. So I think all of you know about this. I think understood these root words. And you have to remember at least 10 first of all. And later we can do remembering remaining also. So here I think you got clarity about root word here. So let us go. So here one more point I want to say here. Common root word. Common root word. Commonly one name is there. What is that means? Alk. Alk is the common root word name. So here alk represents number of carbon atoms in the longest chain. Because one point here, just of all so many one class is there. In that class so many girls are there. Here girl is the common name. But again each one having individual their names are there. Okay. So like that girl is a common name. And again, all are having their names here separately. Like that here also, so many root words are there. But common root word is what here? Alk. Okay, boy is the common name. Again, so many names are there here. Okay. So like that. For example, if you see in this participants here, some boys are there. Gayatri is there here. Okay. So like this, Sansita Reddy. So these are their individual names. Sahasra. Okay, but commonly they are all girls. Girl is the common name. Here also here root word means alk is the common root word. Common name of the root word is alk. But we can change their names based on the number of the carbon atoms. Okay, so this is about here common root word. So root word means number of carbon atoms present in the longest continuous carbon chain. So next, another important term I told you regarding suffix. And what is yeah?
What is the name for 33 carbon, sir?
Yeah, I got here. I wrote already 33 tricant. Tricant is the 30. 3 means again tricant. Okay. So first 10 most important. You have to remember. Remaining as your interest. Okay. But easy on. Yeah.
Sir,
Yeah.
up to 100 only will be there, 100 only carbons.
But in the books also available up to 100, I think here. Okay, na? Up to 100 only available. But also,
Okay,
actually, we require 10 only. Or maybe in few books, they are giving 11 to 20 also. Sometimes they are giving examples. But maximum, we have to know at least 10 minimum. Okay, na? So next is suffix here. Suffix means what?
Okay, sir.
Before going to suffix again here, two types here suffix. What is that here? Primary suffix. and secondary suffix. Suffix again two types, primary suffix and secondary suffix. So first of all, what is primary suffix? Here primary suffix means here generally this primary suffix is always added to the root word to indicate the nature of the carbon chain. Here primary suffix indicates the nature. So that means, for example, all are single bonds. Single bonds. So then we have to use the suffix "an" only. If any one double bond is there between any two carbon, at least one double bond, then we have to use
In.
"in" is the primary suffix. If at least one triple bond is
I-
present, then we use the suffix "ein." Okay, but this suffix is generally added to the root word. That means generally common root word. I told you alk. Common root word is alk. Common
Alk.
root for this alk we are just you adding "ein."
Alkane.
Alkane. Here we are adding "in."
Ein.
We are adding "ein." So alkane, alkene, alkyne. Two are actually unsaturated. So this is the nature. This is what here saturated. And already we discussed about this classification already before. Okay. So saturated means all are single bonds only between the carbons. But at least one double bond. Then we are going to write the after root word we have to add "in." After root word we have to add "ein" when at least one triple bond is present between any two carbon atoms. So this is about the primary suffix. And you can ask one doubt now here. If two double bonds are there, then how? Two double bonds. Simple. Okay, I am giving here two double bonds. If two double bonds are there here, then how to? So two double bonds are there. I am giving one name, alk, and here you have to use "a" also, alka. Okay, if more than one double bond is there, we have to use alka. And here diene. Ene means what? Double bond, we know already. But di means how many times are there? It is two times. So two times means we are using di. Okay, this di is called numerical prefix. This is called here numerical prefix. Generally, di. Or if I am giving three times, then three times means alka common, but triene. Tri means three times. So tri also numerical prefix only. So a di represents two times repeated. Tri represents three times repeated. Okay. So like that here, then one double bond or triple bond, we can use these numerical prefixes. But in that case, along with root word, you have to use the letter "a" also. Now let us take one example I am giving. So you can say now
Sir, if
CH2.
three double bonds,
Yeah, three double bonds. Triene, I wrote here already.
4 means tetratriene.
Yeah, as usual. Okay. So now, so I am giving one example
sir,
here.
if two triple bonds are there, ma'am.
Yeah, diene. Two triple bonds
triple
is
bonds.
diene. Diene. Two triple bonds. Diene. Okay. Three triple bonds. Triene. As usual, numerical prefixes are common. Okay. So I am giving one example here. In this example, I am selecting the longest chain. This is the longest chain, continuous carbon chain. Continuously carbons are there. Now, how many carbons are? 1, 2, 3, 4. 4 carbons means what we can write the root word? But. And here all are single bonds only. So you can add the primary suffix again. So this is butane. And one more example I am giving CH3, CH double bond, CH2. In this example, this is the longest continuous carbon chain. And how many carbons here? 3. So 3 means root word prop. And here one double bond is there. One double bond is there means "in." Simple thing. Where here we have to remember the root words. Okay. And I am taking one more example. CH triple bond CH. Yeah, this is the continuous carbon chain. Now here 2 carbons only is there. So root 2 for 2 carbons. Root word is eth. And the triple bond is there. So ein. Ethyne. Okay. Okay. You can ask one more example. I'm giving here. I'm giving now here 2 double bonds. So 2 double bonds in there. This is the longest continuous carbon chain. So 1, 2, 3, 4 carbons are. So but more than 1 double bond is there. So buta. Okay, if more than 1 double bond, we can add a letter also extra additionally. So now here double bonds, how many are there? 2 double bonds. So numerical prefix di and yin 2 times. Yin means double bond, di means 2 times repeated. A means if more than 1 time you have to add a, but is the root word. Okay, so here but is the root word, di is the numerical prefix, yin is the primary suffix. Clarity here. This is primary suffix. This is
Sir, in case of one
numerical
double bond and one triple bond.
prefix. I wrote already before. And this is the root word. Clarity. While you are writing the name, the part name also you have to know which part it is. It part belongs to which one. So this is about example, and one more example also I am giving. Yes.
If one double bond and 2 triple bonds will be there.
Then both also we have to write here. Both we have to write. In and in, both we have to write. And later I will give that type of examples also. No problem. Now just I am giving few examples, and again we will get that. If both are there, then how to write? I will tell you. Next we are getting rules also. Now in this example here, 1, 2, 3, 4. 4 means but di 2 times. Who is repeating 2 times? Triple bond. So in, like this. So these are the few examples. Okay. Again, we are going to discuss few rules. In that, everything you will get the clarity. Okay. And next year, secondary suffix. Primary suffix we discussed now. Secondary suffix. These are direct point only. Secondary suffix means, first of all, it represents the nature of the functional group. If any, already we discussed the functional groups in the previous classes, types of functional groups. So, which functional group is present in the compound, we can identify based on the secondary suffix name. Because each functional group having one name, like here also how we are writing root words for each number of carbon atoms. Here also, for each and every functional group, we are having one secondary suffix name. Based on that name, we can identify which functional group is present. Nature of the functional group we can explain. Let us see here, alcohols is one of the functional group. And I told you before also, if alcohol is there and in the structure they are giving OH. OH means what? Alcohol functional group. Then how to remember and how to write while you are writing the name, we have to write whole. Okay, we have to add whole in the name. If whole we are writing, then it represents alcohol functional group, and in the structure OH is there and its name is whole. This is the general name, this is structure, and it is name, secondary suffix. This whole is called secondary suffix. Another example of functional group, aldehydes. I wrote already before, CHO group is there. If you are observing the structure, if CHO group is there in the structure, then that functional group is called aldehyde. But how we are writing the name, if aldehyde is present in the given compound, then AL we have to add. All. This is whole, this is all. All means aldehyde functional group. And in the structure, this part is present. And ketones, if you take here, so ketones means like this, we are giving structure. In the structure, if you observe, this type of structure is present here. In the structure here, okay, na? Then if this part is there in the given structure, then we have to write in the name one. Okay, this is just names we have to add for that root word and primary suffix. These also we have to add. So based on this secondary suffix, we can identify which functional group is present in the given compound. If whole is there, then alcohol is present. Okay, if all is there, aldehyde is present in the structure. If one is there, that is nothing but ketone. Or if I am taking carboxylic acids here, then COOH. Here we can say oic acid. And later now, one by one, we will discuss clearly about these functional groups here. This is the secondary suffix. Or if you take acid amides, these are all the types of functional groups. So many are there. Just important functional groups we are going to discuss now. CONH2. Okay, this part of structure present in this is actually it's a secondary suffix is here amide. Or acid chlorides if you take here acid chlorides here COCl. This is called here oil chloride. Oil chloride here because chlorine is there. Or if you take esters as another functional group. So no need to confuse. Again, we will discuss each and every one clearly. Okay, so here OH we are getting. Okay, these are the some examples of functional groups and their secondary suffixes. Or you can take nitriles. Nitrile,
after what, sir?
EN. Yeah, COOR. This is OAT, OATE. This is oil chloride.
That's your formula.
What formula? This is COOR. This is COCl. This is CN.
Okay, sir.
I will give an example now. Let us see a few examples here. CH3, CH2, OH. So this is the example I am giving. In this, I am asking you what is the root word. How many carbon atoms in the longest chain? Carbon atoms only. Root word will be 1, 2. So eth. So all are single bonds only here. So what is primary suffix? In. But E also is there. But here when secondary suffix also is there, then just we have to exclude this letter. We have to no need to write. And what about secondary suffix? Here secondary suffix means OH. Functional group is OH. For OH, I wrote in the table. Here, whole. Okay. So secondary suffix is whole. Now add these three names. Then whole. If whole is coming, this letter we are removing here. Ethanol. Okay.
Sir, can you show the entire table for 2 seconds?
This table.
Yeah,
No, again, I will tell you all this. Just I giving examples only. Again, everything I will tell you again. Each and every one we will explain again.
okay, sir.
No problem. So this is an example here. I think you understood here alcohols. So alcohol means OH group is present in the given organic compound. Then we have to see the root word. And then primary suffix means "-en", secondary suffix means "-whole", and you add all these. Simple. We will discuss again each and every functional group, no problem. So just I am giving one example. And now here regarding prefix. So prefix, another part. And here also again two types prefix. What is that? One is a primary prefix. And the second one is here secondary prefix. Primary prefix, secondary prefix. So first of all, regarding primary prefix, where we have to use this. Also, first of all, what is primary prefix? It is very simple thing. Only one word. That word is called primary prefix. What is that word? Already I told you in the classification. Cyclic compounds we discussed before. Cyclic means ring structures. For example, I am giving one example here. In this ring, how many carbons are there in this ring here? I am taking one example here. 1, 2, 3, 4, 5. 5 carbons. So 5 carbons means pent. Okay. And all are single bonds. Single bonds means what we are using? Ene. Generally, I am writing one more structure here. CH2, CH2, CH3. Even here also 1, 2, 3, 4, 5. Pent only na. All are single bonds. Ene only na. Then what is the difference between this structure and this structure? This is open chain. This is a closed chain. So we have to differentiate both. Both are pentanes only. But we have to differentiate in the name. This is ring structure. That's why we have to use one word. Cyclo. We have to use cyclo because it is in the ring structure. It is in the closed structure here. 5 carbons are closed here. Okay. When they are closed here, then we have to use one word, cyclo. So this is pentane only pentane. But what about this compound name is cyclopentane? I think you understood difference. Cyclo means these 5 carbons present in the ring form. But here I am not representing, I am not mentioned here cyclo. So that means they are in the straight chain only. These 5 carbons in the straight chain. When we are mentioning cyclo, you have to write that 5 carbons in the ring form. I think you understood. So this cyclo, this name is called here primary prefix. Primary prefix means what here? In the ring compounds only we are writing this primary prefix. And always primary prefix means cyclo only. No other word we should not call primary prefix. One and only the word cyclo is always called here primary prefix. Okay, no other words are there. Primary prefix means only one word. That is always cyclo only. But root words are so many. Primary suffixes are 3, N, E, 9. And secondary suffixes, based on the functional group, we are giving different secondary suffixes. But primary prefix is always one word only. That is always cyclo. Cyclo is primary prefix. Primary prefix is cyclo. No other words are not belongs to primary prefix. Okay, clarity. In the cyclic compound only, we can write this primary prefix because there's we are writing cyclo. Otherwise, there is no primary prefix is present. No primary prefix present in the structures without ring form. And this is about primary prefix here. Next, another one, secondary prefix. So secondary prefix here. Now, I will give one chain here. You can understand now easily which type of groups are called secondary prefixes, which compound. First of all, I am giving one chain here, CH3, CH2, CH, CH3, CH2, CH3. This is the example I am giving. And first of all, who is the root word? Here I told you one point in the root word. Longest continuous carbon chain is called root word. Longest means you have to select from this side we are going. Any side continuously you have to go. So this is the longest chain. Is it correct or not? 1, 2, 3, 4, 5. And somebody they are drawing like this also. Same compound I am taking. I am taking the longest chain, this one. Is it correct? This is longest chain. Actually here 5 carbons are there in the chain. But longest continuous carbon chain, if I am taking in another way, in this way, 1, 2, 3, 4 only. So here 4 carbons in the chain, but here how many carbons? 5 carbons. Which one is the longest chain? Continuous carbon chain, this one only. But this is not a longest chain. So this is the correct structure. And first of all, we have to select the longest chain. Because root word means what I told you. Number of carbon atoms present in the longest continuous carbon chain. That is only called here root word. Clarity here. So in the second example, this is not a longest chain because it contains only 4 carbons. But there is a possibility to select the longest chain having 5 carbons in the same structure. That's why we have to select the longest possible continuous carbon chain only. Okay. In the same structure, we can select one more possibility is there. So maximum possibility you have to take the longest chain which contain the more number of carbon atoms. So this should not write here and this one only we have to take. So now in this example, 5 carbons. So here this is the correct numbering here. We are giving here correct representation. Now I am asking you what is the root word in the compound here. In this compound root word means 5 carbon longest chain. So yes, pent. And all are single bonds. So N. Pent. But there is some difference. What is that here? Yes, there is some another part is there in the side of the parent chain. Actually, we are selecting this longest chain. This chain is only called here parent chain. Before I told you parent chain or longest possible chain here. Okay, parent chain, okay. But along with parent chain, there is some side chain also is there. Okay, now this is what? Side chain. So this side chain is nothing but contains how many carbons here in the side chain? 1 carbon.
One.
1 carbon means meth, and for the side chains we are using aryl. Okay, for side chains only. So methyl. Clarity here. This side chain is called secondary prefix. Nothing but this side chain is also called substituent. This is also called what? Substituent. So here substituent is what here?
Sir, what is the difference?
CH3 means what? Methyl. So one carbon, but it is not complete structure here. CH3 is the just a side part of the chain. So that's why we have to use yl, methyl. Okay, clarity here.
Sir,
Yeah.
what is the difference between both of?
Yeah, I will give one clarity here. Methyl. What you're asking regarding methyl? What is your doubt?
Structure, sir.
These
Regarding
two structures,
structure, sir.
both are same structures, but longest chain we have to take. That is important. This is the longest possible chain, and we have to say the root word for longest continuous carbon chain only. That's why I'm selecting this is the parent chain. Okay. I'm telling you structures are same, but root word we have to select for longest possible continuous chain only, not for like this. This is the least structure, least number of carbons are there, less number of carbons when you are selecting the parent chain, because we have to select the parent chain. First of all, parent chain means what? Longest possible continuous carbon chain. I will tell you one more example here. So if I'm taking like this here one carbon is there, and here few more. So here if I'm taking, you have to select the parent chain in this. Parent chain means what? What is the meaning? Longest possible continuous carbon chain. So I'm taking you straight chain. We can take one possibility. Is there any other possibility to select the longest chain? Okay, somebody is drawing like this here. Is it correct? Is it longest continuous carbon chain? Here 1, 2, 3, 4,
No,
5,
sir.
6, 7, 8. Here 8 carbons we are getting. But here 1, 2, 3, 4, 5, 6. 6 carbons. But we have to select the longest chain having more number of carbon atoms. So this is the correct. This is wrong. Clarity here. So what is the root word? In the given structure, oct only root word. But if you are writing hex, this is wrong. Because there is a possibility to select the longest chain. So we should not write hex. If any possibility is there, then you have to select the longest chain. Longest possible. So oct is the correct root word for the giving structure. Understood here? Any doubt here?
No.
Sir, for this, what is the root word, sir?
Yeah, I wrote here oct, 8 carbons.
Like prefix, secondary prefix.
Secondary prefix here, 1 carbon only is there, side chain. So methyl only. 1 carbon means methyl. Yl means side chain. Okay. Nothing but a common name is alkyl. Again, we will discuss tomorrow about alkyl also. Again, I will give the clarity. Side chain is methyl. But yl, when it is coming yl for the side chain or substituents. I will tell the clarity here again. So I am giving one more example here. Let us see this structure. What is the root word in the structure? What is the root word here in the structure?
Bute.
Okay. Generally, if I am taking straight chain, I am getting 4 carbons. But I am taking like this, longest continuous carbon. This one also like we can write. Here how many? 1, 2, 3, 4, 5. Here 5 carbons we are getting the longest chain. Okay. You can select the longest chain continuously, means you can take like this straight chain, or any way we can go like this down. Okay. Or like this longest possibility we can select here. Straightly you can go. Okay. Or any side only, but you should not come back again. If you are going to one side, again you should not come back. You can take like this and go. You can go longest continuously. Continuously, either you can turn to right side or left side, or you can take different turnings, but you should not come back again when you are selecting. Now here in this example, I am going like this here. This is the longest chain. Okay. Now how many carbons here? 5 carbons. So this is the parent chain. Parent chain contains 5 carbons. It is correct. It is wrong because there is a possibility Most number of carbons we can select for the parent chain. Clarity. If I am taking like this, once see clearly. Can you say longest possible chain contains how many carbons in this? Yeah, if you are going to straight, only 5 carbons. Okay. But if I'm taking like this, how many? Because you can take like this also, continuous chain only. This is also 1, 2, 3,
7.
4, 5, 6, 7. Is it okay? If you are taking straight, wrong, 5 carbons. Somebody, if anyone, no need to confuse here. Just check once again. Somebody type, if I am taking like this, is it correct only? 1, 2, 3, 4, 5, 6 only we are getting. But in the first one, this is the first numbering, second selecting point, the third. Here 6 carbons, here 5 carbons, but here 7 carbons. So this is longest chain. Clarity here. Longest continuous chain. Longest continuous chain, any side you can go. Okay, longest possible carbon chain, you can go any side like this here. Or any side you can go like this. Carbons. Okay, but we have to get the more number of carbon atoms when you are selecting. That one only the parent chain or longest chain. Clarity? In that, how many carbons are there? That is called the root word. And root word is mainly different from different number of carbon atoms. Now I am selecting 7 carbons. So 7 carbons root word is what here? Apt. So you have to remember at least 10 root words first of all. Okay, now. Any doubt here up to here?
Sir, prefix is ethyl, no sir?
Come again? Yeah.
Prefix.
Prefix here, not ethyl. Ethyl means 2 carbons continuously like this. This is called ethyl. Here separately 2 carbons, 1 carbon is this side, 1 carbon is this. So dimethyl we can write. Okay, na? 2 times single carbons are there. Again, I will give clarity again. Again, we are getting all these rules again. So once you see here, if I am taking, so if you are asking, that's why I'm telling this example. If I am taking, this is the longest chain, then what is this here? Continuously 2 carbons. So this is ethyl. Okay. One side chain, 1 carbon containing side chain, methyl. If the side chain is having 2 carbons, this is the longest chain. Here, this is the side chain, ethyl. Okay. If the longest chain, this one, and the 3 carbons are there, this is called here propyl. These are the what? Side chains or substituents we can call. Okay. So
Okay.
tomorrow we will continue again. Main rules we are getting tomorrow also. So listen carefully, but very easy one.
Sir,
Yeah, ask.
to that we can do like L shape like that we can get, sir.
Yeah, here L shape also we can get same. Yes. Yeah, this is also longest chain only. That is also correct one. Because both are containing how many carbons here? 1, 2, 3, 4, 5, 6, 7. Yeah. Okay.
Okay, sir.
Yes. So we will continue tomorrow. Yeah. Sir, Ranga sir. Ranga sir.
Sir,
Yeah, ask.
in before one you told dimethyl, no sir. In this example you told that is as ethyl.
Both are different, Amma.
Okay.
Because if 2 carbons are continuously is there in the side chain, this is ethyl. but the two carbons are separately.
Okay, sure.
Okay, understood here?
Yes, sure.
Okay.
Thank you very much, Jagdish garu.
Okay, sir.
Thank you to all. Tomorrow we will meet again. Thank you.